Page 1, here are the notes for 9.3 day 2. So a quick goal update. We can solve linear equations like 4x plus 2 equals 0. We just solve by getting everything away from the x. So can we use this same knowledge to solve for quadratic equations in the standard form that we talked about? Well, yesterday we worked on factoring, and that was breaking it down into the pieces so that it was in parentheses. Today we're going to use that exact same knowledge, we're just going to take it one step further. So our first step is to set equal to 0, just like we did yesterday. Set equal to 0. That means if there's any terms on the right-hand side, we're going to move all the terms to one side so that we can set it equal to 0. That's going to come in handy later. Once we've done that, we're going to factor using the same properties we did the other day. And a factor ends up in this form. It ends up in the parentheses. So if you recall from yesterday, we do this by finding what multiplies to C and adds to B. In this case, it's the pair positive 2, positive 4. And we put it in this form of x, 2, 4, positive, positive. Now this is where our second and third step come in. Once we've factored it, we are going to use the zero product property to solve. And when something asks us to solve, we want it in the final form x equals or a equals or our variable equals a number. So if you recall our zero product property, that says that a times b equals 0, mean that either a equals 0 or b equals 0. So if we use this little side note cloud, this means that either my first term equals 0, and I can say x plus 2 equals 0, or my second term equals 0, so x plus 4 equals 0. Now, this is the exact same thing solving as this is. This is now linear, and all we have to do is solve for x. So x is either negative 2 or x is negative 4. Final answer, x is either negative 4 or negative 2. However you want to write it is fine, as long as I can tell that there are two answers. Now, how do we know there's going to be two answers? Well, most often we can tell by this little square up here. The highest degree of our equation is going to tell us how many answers there could be. It doesn't mean that's how many there are, it just means that's how many are possible. So in this case, the maximum number of answers we could have is 2. Oddly enough, we end up with 2 answers. Let's see this again. So I'm going to factor it the same way I did the other day. And I'm not going to go hard into factoring just because that was the primary goal of the other day's lesson. But I'll show it for the first few here. The only factors of 3 are 1 and 3. So I know that it's going to look something like this. The trick is recognizing that if this is a negative and this is a positive, then both of these have to be negative. Once I have it factored and it's still set equal to 0, I'm going to set each of these things equal to 0 using the zero product property, and then just solve. X either equals 3 or x equals 1. And because I'm just very organized, I prefer to put it all as one answer. You can put it here and just leave that and circle it, as long as you don't forget that you need to circle both answers and not just one of them. All right, let's see a few more of these. Again, I'm not going to go into the factoring, but it should look something like this. Y minus 4, y minus 1 equals 0. Set that equal to 0, set that equal to 0. I am going to slowly start pulling out some steps here. So y either equals 4 or y equals 1. Notice in that step, I didn't show the factoring. We need to start recognizing that the factors of 4 are either 1 and 4 or 2 and 2, and you can only get 5 by using the 1 and 4. All right, let's go again. This one, m plus 9, m plus 1 equals 0. I'm now going to pull out this step. I'm not going to set each of those equal. I'm just going to do it in my head. If m plus 9 equals 0, I know that m has to be negative 9. I'm just going to follow that one. If m plus 1 equals 0, I'd move the 1 over and it would just be negative 1. So I'm going to start showing less steps there. All right, a few more. These ones you'll notice are not set equal to 0, so we have to do that first step by moving it over. So x squared plus 5x plus 6 equals 0, and then the process just stays the same. X, 3, 2, positive, positive. X equals negative 3 or negative 2. All right, move the x over. Plus 3x minus 10 equals 0. 5 and 2. Positive 5 and a negative 2 will get me a positive answer. X equals either negative 5 or positive 2. This one's a tricky because we not only have to move the 9x over, but also the 2. So you get x squared minus 8x plus 7 equals 0. All right, 7 and 1 ought to do it for us. They both need to be negative. So x can either equal positive 1 or positive 7. All right, last one and my favorite one on this worksheet. On these notes. Quick application. So we can give the formula of any projectile, something that's thrown, kicked, or put into the air. The formula is right here. And this is going to be a really common formula. So if you ever take physics, you're going to see this again. So we know the height, h, the projectile after t seconds, and the initial velocity. So if we take this in a specific example, in football, a punter kicks a football with an initial velocity v of 48 feet per second. So I like to do word problems like this. I like to write on one side what I know. I know my formula, and I know that my initial velocity is 48 feet per second. My unknown, or my want to know, is how many seconds it will take for the ball to return to the ground. So t equals question mark. Well, let's think about this a little bit further. If I draw a picture over here, as time goes on, what does the ball's height do? Well, once it's kicked off the ground, as time passes, it's going to go up in the air, and at some point, it's going to reach its maximum height and come back down. So at time 1, when it's on the ground, time equals 0, it hasn't left the ground, it's still on the ground, so its height is 0. At some point, it's going to reach a maximum height. We don't know what that is. But when it comes back down at time 2, this is time 1, at time 2, we don't know what that time is, but we do know that its height ends up back at 0. So I'm going to add this to my known. I know that the time that it goes back to the ground, starts on the ground and ends up back on the ground, the height is 0. Let's now take that and plug it in. If I know that my height is 0 and it's equal to an initial velocity of 48t minus 16t squared, by plugging in my h and my v, now all I have to solve for is my t. Well, this is a binomial that we learned to factor in a previous lesson. So what do they have in common? In this case, they're going to have a 16 and a t. What's left over in the first term is a 3. What's left over in the second term is a negative t, and it's still all equal to 0. Now, based on what we know about the zero product property, we know either this first piece has to be equal to 0, or the second piece has to be equal to 0. When I set the first piece equal to 0, I see that time is 0. Well, funny enough, we actually already knew that. We know that time 1 is when it starts, or when it is kicked. So I automatically know that this is time 1. By solving the other side of the equation, I find out that my second time is at 3 seconds. So at time 2, we hit 3 seconds. So the second time that it hits, or the second time that it reaches a height of 0 is when it hits the ground, and that is after 3 seconds have passed. So when it asks us how many seconds will it take for the ball to return to the ground, we now know that it takes 0 seconds to start, and it takes 3 seconds to return to the ground. And all we had to do was know how to factor. All right, lots of practice is going to help you get really, really good at this. So please practice a ton and let me know if you have any questions.